Well, good day.
Good
Welcome.
day. Hey there. Welcome to a new episode of Alfatron Chats. I'm Noel, and with me in studio today, Michael van Rensburg. But today, we've got an extra bonus for everyone. We have a very, very special guest online with us, Richard Jonker, specialist for AV over IP at Netgear. Welcome to the show, Richard. Good to have you with us.
Thank you, guys. Welcome to this wonderful opportunity. Really nice to be able to join you here today. Let's make it fun and informative.
Absolutely, yes.
Good. Thank you, Richard.
So Richard is here with us today to talk about ProAV switches from Netgear. In specific, the M4250 and the M4300. Richard, you're with Netgear, the global networking specialist. What are the issues that you guys see with audio and video over IP?
Yeah, thanks very much, Noel. So Netgear have been selling business switches for the last 25 years. We sold over 100 million of them, and you may have seen these here. Those are unmanaged, lightly managed 5 or 8 port switches that do what switches need to do, right? They just connect stuff. It's just for audio video, you need a few things more, right? You need to have a network that understands video, that can process it, and that can make sure that you deal with things like multicast. Multicast means you go from one source to a few targets on the network. Not every target, that would be called broadcast, and not just one target, that's called unicast. It's usually something in the middle. A multicast is hard because you need to structure that, and you need to make sure that even if you do this over multiple switches, there is traffic going to the right target, but not everywhere. That's the main issue, particularly in larger networks, particularly if you have a whole bunch of video sources and targets that you could compare it as being a policeman in the middle of a large city square, and there's this traffic coming from 4 sides. You don't even know where to begin. So the switches you use for an AV over IP implementation need to have that intelligence, and then of course they need the raw processing power to deal with video streams that sometimes fill up the entire bandwidth on a switch. True. So that's why we recommend to use approved AV over IP switches for an AV over IP installation, and not just a standard unmanaged switch, because it will choke as soon as you add a few sources and a few targets.
Absolutely, yes.
So in, let's say in the networking world, there are certain rules for a network that you need to respect. And we found there are issues with network design in general that get amplified when you are designing a network for AV over IP. So we've made a top 10 of AV over IP network design tips that I would like to share at this point. So I'll quickly run through, and Noel and Michael, please ask any questions or stop me when I go thoroughly overboard. But most important is, and I think we can go to the first point, is that you start immediately to use switches that have the right professional grade, and you design a network properly. And that means with the help of Netgear, we have that design team, you use the approved switches for AV over IP. That means approved not just by us. I mean, we can tell you anything, right? But approved by our valued partners like Alfatron. They have tested our switches and they approve them for use with their application. I mean, that's way more important than what I say. It's what the AV over IP manufacturers in the world say. And we have close to 100 now that collaborate with us and that make sure that we have all the settings that are necessary to make this work either out of the box or very quickly. And we'll talk a little bit about what is needed in order to accomplish that.
Fantastic.
Yeah, you have to start somewhere, and I think that's an important point. Is you have to understand the basics of AV over IP before you start putting these networks together. I think that's we'll look a little bit at that element as well. So with Alfatron, we are also working on making training material available. We have training material ourselves. So as you can see here, there are a couple of areas where we do that. First of all, there is the fundamentals for AV over IP. I mean, what is it and how is it different from traditional AV protocols like a switcher with HDMI, for example, right? How is AV over IP handling things like multiple video streams? On Netgear.academy, you can just make a free account and follow these courses for free. You get, even on the first course, you get 15 AVIXA points. So that is quickly earned, 1 hour of training, and then you are trained on AV over IP fundamentals. Alfatron has trainings more specific to their solutions. And there are other groups of companies under different hats that have training for ecosystems like SDVOE or Audinate's Dante. You see that right here. So that is important, right? You got to understand a bit how it works. And then the next phase is how do I design a network, right? And what do I do in order to make sure that it works? And, you know, where it always starts is ask the right questions, right? You got to find out the requirements from your customer. And that's not just, you know, customer wants a Zoom room or a video conference facility or wants to do an LED wall. It goes further than that, right? It's really identifying what sources are there for audio or video, where do they go, what targets are there, and you know, that's you know, the transport of the signal. It is the origin of the signal and the destination of the signal. Those things you will need to figure out. Is it all about quality? Is latency very important? You can imagine if you are designing a network for a robotized surgeon that sits on one side of the internet and with a camera on the other side of the internet filming a patient, then latency is king, right? You don't want that there is a delay because we don't want to cut through too far during an operation. But you can also imagine that showing footage in a retail store, it can happen with a little bit of latency, but you want a decent quality. Now, those are two knobs and they do influence each other when it comes to network design. So it's good to have those understandings. And then ultimately, when you group these sources and these targets together, maybe on one switch in one location, there is a necessary uplink speed that combines all of it towards an aggregation. And you need to then, you could say calculate almost what the necessary upload is, and then design the network to support that. So that is what we say as find out the requirements. And yeah, we can help you ask the right questions there. So in order to go and figure that out, you have to then write down these requirements, list them, and then do the math. Once you have calculated, for example, you know, you have 8 cameras and they're connected to one PoE switch that does support AV over IP protocols, and that's good with multicast. I mean, all of that is in order. You still will need to think, right? For example, if it's 8 Alfatron cameras, they're all connected on 1 gig, it will work on 1 gig switch. But what if the combined throughput from those 8 cameras on one switch is more than 1 gigabit? Then you can still say, okay, I can do a link aggregation on the uplink. I do 2 cables of 1 + 1 gig, together 2 gigabit, it may still work. Well, yeah, that's true. But maybe if these cameras put out more, maybe more than 100, 150 megabit each, then yeah, a 1 gig or a 2 gig solution may not be enough. Now, if you go to 4K or you run other forms of audio and video over the same switch, you may need a 10 gigabit uplink. And maybe you want that in fiber because, well, that's how your building has been wired. In that case, you know, it would be good to choose for 10 gig because then you build in the headroom as well. As a rule of thumb, we say, well, you have about 70% of load on the switch in a normal situation. That's about the maximum. So you have 30% headroom. But you could think of a solution where you want to add more video sources in the near future, then it's probably better, more effective, and also more financially efficient to immediately install a larger switch with more uplink speed. So you solve that problem that may occur in the future. So one of the things we usually say is, if you want a non-blocking architecture, you take all the downlink ports, so any port that has a camera or a video source connected to it, and you just add that up, right? That would be truly a non-blocking solution, which means for every 10 1 gigabit ports, you would have a 10 gig uplink. It's not necessary for a normal AV over IP 1 gig solution, but that is, in an ideal world, you would do something like that. So in essence, it's then calculating, right? It's just adding it up. Now you've added up the necessary speeds. You have designed how fast the network is going to be and how fast the uplinks are. Now you can start designing it based on applications. And what I mean with that is, the advice from Netgear is, and we've seen this in tens of thousands of installations, the best practice here is to use VLANs, virtual separated LANs, which means you have one metal switch that has multiple virtual networks running on it. And those virtual networks are called VLANs. And it's a matter of configuring those, which, and I will show you that later, is not hard, but it's necessary. It's necessary for a few reasons. First of all, you don't want all traffic to be mixed up, and you don't want all traffic to go everywhere, particularly not in a large building where you have multiple floors with multiple switches. You also want to separate audio and video and to make sure that you secure a certain quality of those different signals. And you also want that devices that are necessary, for example, for video, are not necessarily visible for other people on the network. Just secure it. There is a famous example of a school in, I believe it was in Detroit, that had 6 schools connected to one large network, in total 11,000 people. And someone took over all the audio video encoders and decoders because they were not in a VLAN. A student, 16 years old, was capable of doing that. And he played the Rick Astley video, the Rick Roll, Never Gonna Give You Up, on all the screens in the school. 6 schools, more than 500 screens. Never Gonna Give You Up. He also turned the volume up to max because the audio was not in a separate VLAN. And he made that video and the encoder start every 20 seconds so that the IT staff had no chance in fixing it. So I think that's about 3 reasons why you really should use VLANs in an AV over IP deployment. It's for performance, it's for security, and it's in order to separate the signals.
Richard, if I may interject there quickly, please, if you don't mind.
Yeah.
So what you're saying here, better practice is to create a separate VLAN for each type of AV signal. So you're looking at a separate VLAN for audio and a separate VLAN for video, correct? And basically what it does is it reserves that sort of bandwidth across the network so nothing gets congested. Is that my understanding?
Well, you could say it's a virtual network of roads in a city where you separate traffic. So instead of having a 6-lane highway between Cape Town and Joburg, you would separate it and say one is for trucks, one is for normal cars, and one is for very rich people that have been very successful in AV over IP and they're driving Ferraris. They get an extra fast lane. And then there's traffic lights for everyone because you want to stop the trucks when the Ferraris need to go first, right? So it is more than just bandwidth. It is making sure there is a certain quality of service. And also, just like with a highway, you would not be able to get on that highway every 50 feet or 50 meters, right? There would be a restriction on the entry points, which makes the highway a very fast way of transportation. It's the same here. With a VLAN for audio, you make sure only audio sources get on that VLAN and they get full attention for audio processing. And for video, it's the same. They're on a different, a different part of the highway, and they get full attention for what they're trying to do. What we have found with NDI4, which is, I think, the most popular video camera AV over IP protocol at the moment, if you mix Dante audio with NDI4 video on the same VLAN, it gets messy, right? Choppy audio, cutouts, delays. But when you separate it in two different videos, and again, this is the same switch, right? It's just you assign the ports on the switch that are related to audio to the audio VLAN, and the ports on the switch where you have your video encoders and decoders, you assign to that video VLAN. So it doesn't cost you anything, right? You already have purchased the switch. You're just separating it in different areas, just to make this more clean. I think that's a better way of looking at it. And we will show you in the interface how that looks. I think it is frightening for AV people to understand there's such a thing as VLANs, and then the fact that you have to say, well, I have a base VLAN, what we always call VLAN 1, right? The thing that's just already there when you switch the switch on. And then I need to create another two, one for audio, one for video. Yeah, well, we'll show you that it's 2 pushes of a button and then it's done. And that's some innovation we added, and that separates the AV special switches from generic IT switches, because standard switches don't have all of this. And it's very hard to configure standard switches for audio or video over IP.
Yeah.
So, once you're convinced on the whole VLAN thing, I think it's a very important point. And I think from the top 10 here, this is the most important point. If you don't get that right, you will never have a reliable AV over IP deployment. And this is just intended to scare the hell out of you guys. But, it's there. It's built into Switch. It doesn't cost you anything extra. It's the right thing to do in terms of proper network segmentation.
Yeah, great.
So if I may, sorry, Richard, from an AV perspective, from AV guys, and I mean, I work in the technical side and having to commission these systems and then, log into the switch and so on, VLANs is something that scares me. I fully agree, because as an AV guy, I don't fully understand the intricacies of VLANs and setting up some of the details behind it all the time. And every switch is slightly different in how they're set up as well.
Yes.
Yeah, well, Michael, you're an audio guy. I heard you've been spotted next to the World Championship football not so long ago. And the world has changed since then. Football is still there. It's still the same. Well, the Dutch don't play as well as they did back then, but that's a temporary issue. What you see now is that audio for public address has split in different protocols, right? It's like a religious battle. There's AVB on the, let's say, the amplifier and the speaker side. There's Dante, which you mostly see in business audio and consumer audio. And there's AES 67, which is a protocol you mostly see on the broadcast side. And if you are an AV installer, you have to cater to all of these people, right? Because everyone wants something. I mean, if it's video conferencing, well, it's probably going to be Dante, right? But if there's a broadcast component, okay, can you add AES 67? Well, that works with a different version of PTP. How am I going to do that? And then comes in the public address audio guy who says, hey, can you do this on AVB? Okay, so now you need to do 3 VLANs for audio with 3 different settings if you want to do those protocols on the same switch. It is possible, but you got to have some experience in handling this. And the rule is set VLANs. Once you set VLANs, everything follows from there, and then we can make this really easy. And we did design a user interface to help people do this quickly. As I said, every VLAN would have some physical Ethernet ports on the switch, designated, assigned to it. And there you connect the relevant equipment. That's all it is. Really simple. But that took a few years to engineer, of course, and now it's really simple. But what happens under the hood is pretty complicated, and we will do that for you.
No,
so
good.
There's more to it. If you have an HDMI matrix switcher, you basically have a source, and that goes to a screen through a matrix switcher, and essentially this is one-way traffic, right? You can de-embed the audio and do some other things, but really, it's not a bidirectional protocol as such. So with AV over IP is different. Every port that I call 1 gigabit is actually 1 gigabit in and 1 gigabit out at the same time through the same port. We call it full duplex. And that means you can send and receive. It also means that in AV over IP, an encoder can be a decoder at the same time. That exists, right? Mm-hmm. And it's not that you then physically have to turn the device around, or, you know, if you want to reverse direction, rip out the device and put another device in. These days, that's done in software, and it does use this full duplex element of being able to send and receive at the same time, at the same bandwidth, right? But we only count that once. So there's no trickery here. If we say 1 gigabit port, it means 1 gig in and 1 gig out at the same time, without dividing.
Interesting.
Yeah. Yeah. Well, that's the bonus here. Yeah. So when AV over IP started, people said, you know what we have to do is we just cut up the bandwidth, and we'll then give the highest priority to the most important application, which when I'm gaming at home is my game and not my daughter's Netflix, right? But that kind of, you know, that's a zero-sum game in a way. Mm-hmm. And it just, whatever you say, hey, is more important, you just take that from something else. Now, in AV over IP, that's not working because we're all important, right? Audio and video are both important. And if you have fantastic high-res video, but the voice is choppy, nobody likes that. So QoS is a thing from the past. It was there in the beginning, you know, when we did video over 100 meg networks, it was all difficult. But these days, bandwidth is available. Bandwidth is cheap. I mean, we are selling switches that have 32 100 gig ports, 32, which means you have 3.5 terabit just going back and forth over a switch that costs a couple of $1,000, right? Mm-hmm. Bandwidth is not the issue. Latency is not the issue. The latency on a switch is measured in nanoseconds or microseconds. A microsecond is 1/1,000,000th of a second. Mm-hmm. Video people talk in frames, right? On a 60 frame, you could say, well, that's you know, it shouldn't be more than 15 or 20 milliseconds. Yeah, well, we are 0.01% of that. Don't worry about it. The network is not the issue. The network can be the bottleneck if you don't design it well. Mm-hmm. But in terms of things like bandwidth, latency, or QoS, don't worry about it. We got this. But it is old-fashioned thinking to assume that by setting QoS, you solve all video problems. So as soon as we say, you know, there's a network and there's a QoS problem, we already know there are far more problems than just QoS, right? This is the easiest one. Pretty much you can ignore it now, right? If you buy the right switch, deal with the other issues, which means usually proper VLAN segmentation and multicast, and then you have a network that is far more complex for a couple of €1,000 or dollars than HDMI switches were from the previous technology that still cost $100,000 or $200,000. I mean, those things have dramatically changed, and the network is really solving that in software, right? It does require a different way of thinking. Yeah. But let's say now we know that QoS is not a problem. It's not static thinking. With AV over IP, you virtualize the application, right? It's software defined. So it doesn't matter how many endpoints you have, whether they are sources or targets. It just doesn't matter. Transmit and receive, you can do as much as you want. It can be dynamic, because we learned, could be bidirectional, right? Mm-hmm. Any transmitter can be a receiver at any given moment of time. So that means you can scale AV over IP installations unlimited, literally unlimited. You can keep on adding and adding and adding as long as you respect the design rules, right? Get your uplinks right, get your VLANs right. But if you have 7 switches in a video network and you add switch number 8, you know, if this were an HDMI switcher, then you would have to call the wizard in, you know, the magic HDMI switcher professor, pay him for a few hours, and he does his programming magic. With AV over IP, this would be get another switch, just drop it in, done, right? It would take seconds. That's it. Because it is IP, right? It just thinks like that. So you can easily grow and scale as you want, as long as you do the right setup. Now, of course, networks have a cost in terms of the switch, but that's a fraction of what endpoints cost. And scaling and adding, yeah, is really simple when it comes to that. So knowing that, right? Knowing that the switch is only a fraction of the cost, and all that we want here is audio video reliability, then yeah, rule number 9 here is create a dedicated audio video network. Right? Why having things like office traffic or file transfers interfere with your video? There's no need. Create a separate network. That is the best. And there are some protocols in AV over IP that are fully designed for a separate network, like SDVoE, Software Defined Video over Ethernet. That is a protocol that says we use full 10 gig for 4K 60 video, 4K 60 HDR video, right? It's the highest you can get, more or less. You can even scale that up to 8K. But you would not be able to do that if other traffic goes over the network, right? So we say, if you create a separate AV network for all your AV over IP, segmented in VLANs, that is the best design choice you can make. So converging networks are great. Of course, you need to plug into the office network in the end, for control or for the internet uplink in an existing building. But all this AV, particularly if you want to go higher resolution, it's best to keep that separated. Cost is a fraction, right? Switches are from an average AV over IP install, usually only a few percent. So that's our design advice when it comes to separating traffic. So doing that on a separate AV network is really the best thing to do. Mm-hmm. Then, of course, if you want to stitch it all together and you are going to install very expensive high-resolution endpoints, you select the right switch, right? What's left then? It is the interconnect between the switches. It is changing from fiber to copper. It is interconnect over fiber. Our advice, a module could cost 30 euros dollars or 70 euros dollars. That's not going to make the difference in the total price of your installation, but it can break it. If you don't use the right modules and they start to act up, and we've seen this in installations on airports with 300 screens doing full 4K under full load. This means a network with, let's say, 20 sources and over 300 endpoints. We've seen that break because one of the source was connected with an inferior no-name fiber module, a 10 gig module, right? Then troubleshooting that will cost some time because you got to figure out what component is acting up. And if you then find, someone just ordered a no-name fiber module instead of an approved one from one of the A brands, that's painful. So don't do that. Reliable, proven transceivers, maybe approved ones, right, that have been tested in the solution that you're installing. That is the best way to go. Then your installation becomes more predictable and more reliable. And I think that's typically a tip here that's at the end, but we find that things that go wrong at the end could be the beginning of all trouble. So that's a firm warning. Make sure that you don't use inferior cabling. Cables are cents per meter, so why would you try to save money on that, right? When you spend 1,000 times more on an endpoint, it's really not about the Ethernet cables. So I think to summarize our top 10 tips, it's all pretty logical, right? Use switches that can handle AV over IP that are approved by the equipment manufacturers. Get trained on AV over IP so you know how to design an AV over IP network. Find out what your customer requirements are and then do the math by adding up the uplink speeds necessary, for example. Segment your traffic, use VLANs, although we love the fact that you buy these switches from us. Those are not the ones that you use for AV over IP because they don't do VLANs. So you got to have AV over IP compatible switches and use those features, right, that we put in there. Now, each port on this switch this is an 8-port switch, right? It has 8 1 gigabit ports. So what is the maximum throughput? 8 gigabits? No, wrong. It's 16 gigabit. It's full duplex. QoS is not magic. You know, networking is not one policeman that says what traffic goes first and the rest has to wait. Those days are over. It's all about a design where all applications are properly organized and they can all work on the maximum speed that they require. Now, switches are helping you to design a network for scale, right? Scale up, scale out, no problem. You drop in a new switch and it will just work, which is really much better than with traditional technology. Our last tip when it comes to network design is to create a dedicated AV network. So you have highways for the right AV traffic. That's important for now, but also for the future when resolutions and frame rates go up. You want to have that separated. And cost is not an issue here because endpoints and other infrastructure costs far more than just the networking piece. And the final tip is use quality modules, quality cables, so that doesn't become a bottleneck in your AV over IP design. So those were the 10 tips. I think there is one thing we can help you with together with Alfatron is if you contact us, means Alfatron or us, about a network design, we're here to help. So Netgear has a free design center, which is open 24/7. You can reach us at ProAVDesign@netgear.com. I'm on the email address as well as 14 certified and heavily trained engineers, and they'll help you turn around any ProAV network in minutes. And one of the tools that they use is actually the interface that we have on our product. So if there are no questions yet, Michael or Noel, we can take a look at that. Otherwise, any responses you have to my top 10 here?
Yeah, no, so I think, Richard, I think that's the sort of the main takeaway point is that there's a reason for Pro AV switches. And you guys have brought this product to market because it caters for all the different protocols and all the different things that's required. And like you mentioned, it gives priority to the traffic that needs the priority in that space. And yeah, that's perfect. That's great. Before we just touch on the GUI, we wanted to ask. I mean, there's so many different protocols at the moment and available on the market. Does this Pro AV range cater for all those variables? So the Dantes, the AVBs, the NDIs, the just standard video over IP type protocols, RTMP, RTSP.
Yep, we support all AV over IP protocols. If you want to go bigger and make your AV over IP installation part of a giant cloud, and you're in the professional broadcast world, that means you're working for CNN or for Fox News, then you may think of having also an AV over IP software defined infrastructure in the cloud. Now, we don't provide that. You know, we're the people on the ground that switch AV in any business, right? That's what we do. So in any AV over IP protocol, you can find a Netgear installation, right? We do all of them. We mix them, and we can help you manage the multiple VLANs that you need for this, so that all works properly. I think that's something that we've really proven, and it's the main reason we get recommended by close to 100 manufacturers of AV over IP equipment, including Alfatron, and there are various audio and video equipment makers out there that support your solution. Because you can imagine that in an average installation, you would have equipment already from different manufacturers, right? Speakers, for example, microphones, cameras, screens, LED tiles, projectors. I mean, there are so many manufacturers. We found so far 250 manufacturers that we're talking to, and about 100 have recommended Netgear already. That's not without reason, right? That's because we have figured this out. And we created an interface that people can easily work with to do all those settings, right, without headache. And I think that's the contributing success factor here.
Awesome.
Yeah.
Awesome.
Well, I mean, on that note, then let's have a look at the GUI. just briefly and just show the audience how easy it is. So
Yep.
it should be.
Well, you can see we have on our switches 2 user interfaces when it's an AV switch, right? When it's an IT switch, there's one which we call the main UI. That looks like the cockpit of a Boeing 747 with buttons left, right, front, and behind you. But we have simplified it in the audio video UI. So maybe Michael, you can show us the AV UI.
Yeah.
This is the one. This is from a Netgear M4250 switch. And the one you see here is the one with 10 copper ports and 2 fiber ports. It's probably the best selling one. This is your perfect switch for 1 gig AV over IP that works really well with the Alfatron cameras and the encoder decoders. So the H.264, H.265, NDI, really no problem for this. So what you see here is the overview. And then the most important is to go to the network profiles. You can see the trick that we did in order to make this really easy is we created profile templates for the most used AV over IP protocols, which could be audio, AVB, AES67, Dante, generic data control, video over IP protocols that are generic or very special, combinations of NDI with QSys from QSC or AES67 or Dante. And so as you can see here, for all combinations that we see in the field, we've made a profile. We don't think there are any combinations out there that we can't handle, but these are the most popular ones. So if you need some help with a specific application or combination of maybe 3 or 4 protocols, then please contact us and we'll help you set that up. I can think of control or systems that use intercom on top of existing audio, or a separate system for tele lights if you handle a whole bunch of cameras in a broadcast environment. So we do have solutions for that. Even if you look at let's say a modern day NDI camera, there are a couple of things to think of already, right? In this profile for an NDI camera, you would typically pick NDI4, and then you would put Dante in a different VLAN. Now, if you do that, the following steps, right? You have to select the NDI profile, decide, do you want the camera to get an IP address from the switch, or do you want this camera to be static, right? There's a couple of things that really depends on the brand that you use and the model. You can give it a name, and then you can assign a couple of ports to it. And that's it. These are things that if you have to do this by hand and configure them, or even worse, in command line interface, commands, it will take you some time and you need to really practice that. Here's just following the user interface and then it's done. So I think this is the single biggest reason that people love our switches for audio over IP or AV over IP, because we've made it really simple.
Yeah.
This is really simple. I mean, you literally just click on the profile you want to use, and that's it.
Yeah, and
That's
set
amazing.
the profile.
That is
You
absolutely
assign the port,
amazing.
you assign what it does. Now, many of the devices these days that do audio or video get their power over the Ethernet cable, right? It's called power over Ethernet. And we've put in some PoE, power over Ethernet tools here. For example, you can see the total amount of power that's being consumed right now. So then right, can I add another camera, or is this thing full already? And do I need to plug this 9th camera into another switch? So that's really easy, because PoE is very useful, but you can't see if it's over budget or not, right? And so we've solved that here. And it will also give you a very powerful feature. It means you can remote power cycle any device that's connected to us, right? You just switch off the port, switch it on again, and the device reboots. If you have a conference phone that's hanging, or a camera that's acting up, or and because it's PoE and it's Ethernet, it means from any place in the network you can approach that device, talk to it, maybe update the firmware. All of that is centrally, which means, particularly if you use VPN or cloud to do remote management, you don't even have to be present at that location to do all of this, right? This could be visible from anywhere if you use a VPN, or TeamViewer or something like that, because this is just a simple HTTP interface. HTTPS, I should say. It's definitely secure. And it gives you options to manage the network, only the ones you need, not all the difficult stuff you don't need that we have kept out of this interface. This is just exactly what you need to do a quick turnaround on an AV over IP installation.
Yeah. Well, while you were speaking now, Richard, I just quickly grabbed a network cable here, and I've plugged it into our NDI camera here. That's just boots it up, and I suppose we should get some information back in just a moment about power consumption that it's using.
Yeah, so the moment it starts booting up and taking power, then in the overview view or in the PoE view, you can see that it's active. And then it's a matter of adding the right amount of cameras, the right amount of switches, and then you can build out. Even if you have 40 conference room on one network, you can easily do that with this infrastructure. So M4250 is the name of the product line, our AV line of switches. It's really a revolution. And the fact that it gets recommended with more or less any AV over IP brand out there is not a coincidence, because we made things really simple.
Yeah, I mean, from our side, we engaged with you guys quite some time ago, and we've been using the switch, at least in our testing and demoing and stuff over the last couple of months, and it's been working 100% on every protocol, on every infrastructure, every deployment, every test. You know, it's definitely doing what it's supposed to be doing, and making our lives as AV guys actually quite simple and easy. You know, as you mentioned earlier, that's all cool. You know, we've worked with the other sort of GUI interfaces, especially on the Netgears in the past, but also seen the console interfaces and writing command line. And when it comes to command line stuff, I just say, Mr. IT guy, there you go. You sort it out, and then hope that he actually gets my settings right that I've given him that he needs to configure for that VLAN. To, for instance, do Dante or do CobraNet in the past. You know, if I talk quite some time ago, and you just hope and sort of that he's got it right, and there's no problems happening later.
Absolutely. We say it's only one letter difference between plug and pray and plug and play.
Oh yes, there you go.
You can plug all your Dante and NDI and intercom and video equipment in one switch, then, switch it all on, close your ears, and I really hope it works, right? But, well, often it does. Sometimes it doesn't. And if you follow these rules that we discussed today, whether it's a very simple NDI installation or a more complex, transmit and receive solution with a bunch of encoders, decoders, you can do that with M42 switches as the building blocks under your AV over IP install. And I think, it's been interesting, and particularly since the pandemic, when a lot of meetings became, remote, and a lot of these products were deployed very quickly. I think we saved the day for a lot of installers by creating, a simplicity in AV over IP installations. And, we got the reward for it. We got the recommendations. We got the recognition from the industry. We had our product chosen, the show winner at Infocom, just now the #1 video and audio show in Orlando. So that is some recognition from the industry, and we're very excited to work with Alfatron in deploying these solutions together, because you guys have an awesome, really targeted portfolio of video products, both on the cameras and the encoder decoders. I think for a variety of installations, and it's in the right space at the right time. So it's great to work with you guys on something like this.
No, and definitely the same from our side as well.
Yeah, thank you, Richard.
Yeah.
So, Richard, can I ask you a quick question? So, you mentioned just now that the M4250 covers a whole sort of line of these switches. What differentiates these switches? Is it PoE budget or features, functionality?
Yeah, so we have 3 product lines for audio, video over IP, and the M4250 is our 1 gigabit line.
Okay.
So the models in the M4250 series, there's 11 different ones. They vary by PoE budget. That's definitely one. So it's either PoE plus or PoE plus plus at a new standard, which goes up to 90 watts per port. Our top model in the M4250 line can provide 32 times 90 watts at the same time. So yes, that is close to 3000 watts in raw power. It's a full double height switch. And you would use that when you want to power amplifiers or speakers or lighting or very high resolution encoder decoders that need that level of power, or 4K high resolution, high frame rate cameras with PTZ. I mean, we see more and more deployments there. And they typically come also with 10 gig uplink ports because they typically output more data, right? So higher throughput that comes out of these devices. So that's 11 models in the M4250, mostly 1 gig. And then in the M4300 series, that is the workhorse for 10 gig networking. We have models with 10 gig and 40 gig uplinks, 10 gig ports. So you can create larger installations or installations that require 10 gigabit on each port. And then on top of that, there's the M4500, which is the highest aggregation level that we do. We have a few models there, and they handle over fiber the traffic up to, for example, 32 times 100 gigabit. And that's really what you use in very large installation when you aggregate video from hundreds of sources or hundreds of targets. And there, it still does the same thing as we just discussed. What is unique with the M4250 series is that AV user interface that is really made for AV specialists to quickly install a couple of audio video appliances, devices together in one simple network. But you can even make it bigger and create redundancy by hooking up multiple switches together.
Yeah,
Very interesting.
I think maybe as a last teaser that we spoke about a little bit earlier, for the serious network AV guys that do understand their networking and so on, you know, the GUI interface is there, and it makes it easy for let's call it the layman AV guy, you know, the guy that doesn't understand the in-depth of the switch that well, like myself always. We can still log into the back end as we spoke about earlier. And that's
you could say you have the convenient dashboard and the racing dashboard here. And as you can see on the top, in this main user interface, you have every setting you could possibly think of in managing switches, right? This is full-blown managed switch on the level of the big enterprise networking manufacturers. And don't forget, there's 25 years of experience that went into this. It's consistent over all Netgear managed switches. So any of the managed switches we sell has this interface. You know one, you know them all, and you can do any setting really to the extreme. So the question that we usually get is, oh yes, I've used your AV interface, but I'm missing, you know, I want to do this not symmetric, but asymmetric. Yeah, okay, there's a setting for that. Oh, I want to do this, I want to do that. All these settings are here, and you can see every top row menu has a sub-menu under them with horizontal and vertical. So literally tens of thousands of settings can be done here. Literally tens of thousands of settings. And there's no need to do that if you use the AV UI. If you want to, oh yes, you can go nuts here. You can do anything. And we can help you with that, right? All our technicians are schooled on both of these interfaces. They can help you with any setting. Even if it's very specific, we are very, very, very confident that we know any corner of AV over IP after the work we've done on this. So yeah, happy to help you with that. But usually I would say stay away. Only open the hood of the car when you know what's under it.
Yeah.
Right? Yeah.
In 99% of the cases, no need to open the hood other than to put some new oil in, and then that's it, right?
That's it,
That's it.
Yeah, I'm definitely not going to look at that side of it. I prefer the first one we looked at.
to get scared and then, you know,
I'm
stay
quite
away.
scared right now.
For the technical people, it's there, right? So check that box. It's there. Yeah,
absolutely.
Perfect.
All right, Richard, I think we should wrap things up. It's been an absolute pleasure to have you on the show today, Richard. Thank you so much. It's been a real eye-opener. I myself, I don't know much about switches. I've definitely learned a couple of things today. I'm quite excited. Michael, thanks for arranging this. It's been a real treat to have you on the show today, Richard. Thank you very, very much. Guys,
You're very welcome.
My apologies for that, Richard. Guys, we did put up some links a little bit earlier in the show for the training and all that. We will include that in the comment section as well so that you can easily go through. And if you do need a bit of training on Netgear and all the other things we chatted about, please head on over there. As usual, guys, please don't forget to like and subscribe to our channel, our YouTube channel, so you never miss any content. You can find more information about Alfatron at www.alfatronelectronics.com. Just had to double check that. Thanks, Mike. Otherwise, guys, like I said, please like and subscribe. And thank you very much for joining us today. It was a real pleasure. Richard, thank you again. Absolute pleasure.
Thank you, Richard.
Thank you, guys.
Speak to you soon.
Cheers, guys.
Cheers.
Bye.
Bye.